In this spirit, let's move on to some illustrated examples. Given these quantities, see if you can convert them to a desired system of units. To aid us in this task, we've been given the following equivalencies. Power. 746 watts is equal to 1 horsepower, which is equal to 550 foot-pounds force per second. Watts uses engineer prefixes, whereas horsepower and foot-pounds force per second don't. Pressure. 1 bar is equal to 100 kilopascals, which is equal to 14.5 psi. Both bar and pascals use engineering prefixes, whereas psi's don't. Volume. 1 gallon equals 231 cubic inches. Neither of these units use engineering prefixes. Time. 1 day equals 24 hours, 1 hour equals 60 minutes, and 1 minute equals 60 seconds. None of these units use engineering prefixes. Angle. 2 pi radians equals 360 degrees. Neither of these units use engineering prefixes. And finally, length. 1 inch equals 2.54 centimeters. Inches do not use engineering prefixes. It might be worth a moment of your time to copy these conversions down on your cheat sheet, because one day this material may or may not show up on a quiz. Hint, hint. A brief explanation about centimeters. Despite their popularity, centimeters aren't really official engineering units. 1 centimeter is 1/100th of a meter, or 1 times 10 to the negative 2 meters. If you use proper engineering format, 2.54 centimeters would be expressed as 25.4 millimeters, which is a proper engineering prefix. So you can add this additional quantity to our equivalencies, such that 1 inch equals 2.54 centimeters, which happens to equal 25.4 millimeters. If you had to enter units of centimeters into your calculator, you'd enter it as -2. If the calculator is in exponential format engineering as requested, it will automatically reformat it to proper engineering format, of which centimeters is not an option. It's up to you to do the conversion back to centimeters. I should also note that people unnecessarily freak out about angular measurement conversion using units of radians and degrees, so a little explanation might be necessary. Consider a circle with radius of length r. The perimeter of the circle, i.e. the circumference or outside, has a length of 2 pi times r, regardless of the length of the radius, be it 1 meter or 1 mile. For example, a circle with a radius of 1 meter has a circumference of 2 pi meters, or roughly 6.28 meters, whereas a circle with a radius of 1 mile has a circumference of 2 pi miles, or roughly 6.28 miles. How far you travel around that circumference is respective of the angle. For example, if one traveled pi radians, or 3.14 radians, one would have walked halfway around the circle, or 180 degrees. If, however, one only traveled pi over 2 radians, or roughly 1.57 radians around the circle, one would have walked quarter of the way around the circle, or 90 degrees. Long story short, pi is just a number, 3.1415 blah blah blah, and 2 pi is roughly 6.28. Don't get confused by the fancy pi symbol. It's just a number. To get the most accurate conversion, remember to use the most complete representation of pi available in your calculator by using the second pi key. All right, I do believe we're prepared for liftoff. Let's put your understanding of this unit conversion concept to the test. Convert these quantities to the desired system of units. By all means, pause the lecture and try this yourself. If you're tracking, you should have obtained the following results. Our first couple of problems deal with power conversion. We're first being asked to convert 1.5 megawatts to units of horsepower. The unit we want, horsepower, is on top. Units of watts cancel out. We're left with roughly 2010.7 horsepower. We're next asked to convert 1.5 megawatts to an equivalent amount of foot-pounds force per second. Let's do a single-step conversion bypassing the horsepower intermediary. The unit we want, foot-pounds force per second, is on top. The unit we don't want, watts, is on the bottom. Units of watts cancel out. 1.5 megawatts times 550 foot-pounds force per second divided by 746 watts yields 1,105,898.1 foot-pounds force per second. Again, foot-pounds force per second do not use engineering prefixes, so you're stuck with this rather large ungainly number. Our next problem is asking us to convert 50 horsepower to an equivalent amount of watts. The unit we want, watts, is on top. The unit we don't want, horsepower, is in the bottom. 50 horsepower times 746 watts per horsepower. Units of horsepower cancel out, and we're left with 37,300 watts, or more appropriately, 37.3 kilowatts. We've additionally been asked to convert 50 horsepower to an equivalent amount of foot-pounds force per second. Let's do a two-step conversion. We've already got our value in watts, so let's convert watts into foot-pounds force per second. The unit we want, foot-pounds force per second, is on top. The unit we don't want, watts, is on the bottom. 37.3 kilowatts times 550 foot-pounds force per second divided by 746 watts. Units of watts cancel out, and we're left with 27,500 foot-pounds force per second. Our next set of problems deal with pressure, where 1 bar is equal to 100 kilopascals, which equals 14.5 psi. Units of bars and pascals use engineering prefixes, whereas psi does not. We're first being asked to convert 90 psi to bar. The unit we want, bar, is on top. The unit we don't want, psi, is in the bottom. 90 psi times 1 bar divided by 14.5 psi. Units of psi cancel out. We're left with 6.2 bar. Next, we're being asked to convert 90 psi to an equivalent amount of pascals. Let's do a single-step conversion. The unit we want, pascals, is on top. The unit we don't want, psi, is in the bottom. 90 psi times 100 kilopascals divided by 14.5 psi. Units of psi cancel out. We're left with 620.7 kilopascals. Our next illustrated example is asking us to convert 230 kilopascals to bar. The unit we want, bar, is on top. The unit we don't want, pascals, is on the bottom. 230 kilopascals times 1 bar divided by 100 kilopascals. Units of pascals cancel out. We're left with 2.3 bar. We're then asked to convert 230 kilopascals to an equivalent amount of psi. Let's do a two-step conversion. Taking our previous answer of 2.3 bar, we need to convert this to psi. Psi is the unit we want, so that's on the top. We don't want units of bars, so that's in the bottom. 2.3 bar times 14.5 psi over 1 bar, units of bar cancel out, we're left with 33.4 psi. Next, we're being asked to convert 70 bar to pascals. The unit we want, pascals, is on top. The unit we don't want, bars, is on the bottom. 70 bars times 100 kilopascals divided by 1 bar, unit of bar cancels out, we're left with 7,000 kilopascals. Using proper engineering format, this is more appropriately expressed as 7 megapascals. We're next asked to convert this number to an equivalent amount of psi. Let's go ahead and again do a two-step conversion and convert 7 megapascals to an equivalent amount of psi. The unit we want, psi, is on top. The unit we don't want, pascals, is on the bottom. 7 megapascals times 14.5 psi divided by 100 kilopascals. Units of pascals cancel out. We're left with 1,015 psi. Our next set of illustrated example problems deal with volume and time. We've first been asked to convert 190 cubic inches to gallons. The unit we want, gallons, is on top. The unit we don't want, cubic inches, is on the bottom. 190 cubic inches times 1 gallon divided by 231 cubic inches. Units of cubic inches cancel out. We're left with 0.8255 gallons, or rounded to the nearest tenth place, roughly 0.8 gallons. Next, we're being asked to convert 5 gallons into cubic inches. The unit we want, cubic inches, is on top. The unit we don't want, gallons, is on the bottom. 5 gallons times 231 cubic inches per gallon. Units of gallons cancel out. We're left with 1,155 cubic inches. Next, we're being asked to convert 11 weeks into an equivalent amount of seconds. This is designed to test your understanding of multi-step unit conversions. First, convert weeks to days, days to hours, hours to minutes, and then minutes to seconds. 11 weeks is equivalent to 77 days. 77 days is equivalent to 1,848 hours. 1,848 hours is equivalent to 110,880 minutes, where we're left with 6,652,800 seconds. Our last set of illustrated examples deal with angle and length. We've first been asked to convert pi over 6 radians to units of degrees. Pi over 6 radians are roughly equivalent to 0.5236 radians. The unit we want, degrees, is on top. Units we don't want, radians, is on the bottom. 0.5236 radians times 360 degrees divided by 2 pi radians, units of radians cancel out, we're left with 30 degrees. Next, we're being asked to convert 45 degrees to an equivalent amount of radians. The unit we want, radians, is on top. The unit we don't want, degrees, is on the bottom. 45 degrees times 2 pi radians divided by 360 degrees, units of degrees cancel out, and we're left with roughly 0.7854 radians, which, if you think about it, is a quarter radian. Next, we're being asked to convert 40 centimeters into inches. The unit we want, inches, is on top. The unit we don't want, centimeters, is on the bottom. 40 centimeters times 1 inch divided by 2.54 centimeters, units of centimeters cancel out, we're left with roughly 15.7 inches. Lastly, we've been asked to convert 72 inches to centimeters. The unit we want, centimeters, is on top. And the unit we don't want, inches, is on the bottom. 72 inches times 2.5 centimeters divided by 1 inch, units of inches cancel out, and we're left with roughly 182.8 centimeters. All right, hopefully those illustrated examples went well for you. If not, I'm encouraging you to rewind and revisit this lecture and correct any mistakes you may have made. In conclusion, this lecture took a look at unit conversion. Remember to review this material as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest. We'll see you again during the next lecture of our series. Remember to tell your Lazy Lab partner about this resource and be sure to check out the Big Bad Tech channel for additional resources and updates.